Hi, my name is Travis Ehrenberg, and the title of my project is Polystyrene Decomposition by Insect Larvae and Application of a Catalyst to Stimulate Consumption. So why did I choose this experiment? Well, because quite frankly, polystyrene is destroying our world. Polystyrene takes up to 500 years to decompose, and it makes up 30% of all landfills. And beyond this, 1.3 billion pounds are produced in the US each year. But why is this a problem? Well, because polystyrene is a possible carcinogen, increasing the risk of leukemia and lymphoma. But don't worry, there is hope. In 2015, scientists from Stanford University found that the Tenebria molitor, a type of darkling beetle, can consume polystyrene. So I wanted to take their experiment to the next level by introducing 5 additional types of larvae which can also consume polystyrene and seeing how they compete against the Tenebria molitor. So introducing the competitors, I wanted to use the Tenebria molitor because then I can compare the other types of larvae to the original larvae which the Stanford researchers chose. I also chose the Tenebria molitor with an added hormone which makes them larger and red, which is usually used for lizard consumption. Additionally, I chose the Xephobus moreo. These are known as superworms. They're very large, they can be up to 2 inches long. Then I had the Galleria melanella. What's special about them is that they are a type of wax moth, so they are not beetle larvae like the first 3 that I introduced. Then we have the Dermestes maculatus. They're also known as museum beetles. And then finally, I also used fly larvae called the Hermetia illucens. They're black soldier flies. So after 20 weeks, I gave each of these larvae 4 grams of polystyrene, and I wanted to see which type of larvae can consume the most. So I waited for a 20-week period, and it turns out that the Xephobus moreo, which was my choice of larvae, consumed more polystyrene, a significant amount more. They consumed 3 out of the 4 grams, which is not a lot by any means. 3 out of the 4 grams, that's 25% of the polystyrene, compared to the Tenebria molitor, which barely even touched the polystyrene. But why is this important? Because the Xephobus moreo, my choice of larvae, ate more polystyrene than the Tenebria molitor, which the researchers chose. But if we want to look at the positive impacts of this experiment, we can see that the Xephobus moreo consumed the most polystyrene out of all 6 of these. But the problem was it took a ton of these Xephobus moreo to even consume a small amount of polystyrene. So this leads to the second part of the experiment, the usage of a catalyst to hopefully increase polystyrene consumption. So which catalyst did I choose for this? Well, I chose apple juice because of its low cost and high availability. So I took a piece of polystyrene which weighed 1.6 grams, and I put them in 2 separate containers, each consuming 81 larvae each. After I took the first polystyrene and I soaked it in apple juice, and I weighed it again, and it weighed 2.18 grams after the soak. So I was assuming that it would cut larvae consumption in half. Maybe it would take 10 weeks instead of the full 20 weeks. So after only a 4-week period, the Xephobus moreo had consumed all of the polystyrene compared to the Xephobus moreo without the apple juice, which only consumed 0.21 grams of it. So what does this say? It says that the Xephobus moreo, with the addition of a catalyst, can significantly increase polystyrene consumption. But why is this important? Because what if we wanted to take this to the global scale? What would be the positive and negative impact to this? If we took Xephobus moreo without a catalyst, the main biggest problem would be that it takes a ton of these larvae to consume even the smallest amounts. In the 20-week period without a catalyst, it only consumed 1 gram out of a possible 4. But if we want to look at the Xephobus moreo with a catalyst, we can see that in only a 4-week period, they consumed all of the polystyrene. So if we wanted to take this on a larger scale, we would be able to consume more in a shorter period of time, which is very important because, as I said before, polystyrene is destroying our world. So how could this be applied to the world? Well, if we were to take factories with large pits of Xephobus moreo larvae and then take our polystyrene waste, because polystyrene is very common in things like food containers. So if we were to take the food containers, dip them in apple juice for around a 24-hour period, that's what I did in my experiment, and then throw them in the containers, they would be consumed very quickly in a short amount of time and Xiphoebus mori would be able to consume more polystyrene in also a shorter amount of time. Thank you very much for listening. Have a great day.